All right, this is page 4 of math analysis, notes number 1. And we are now going to start talking about the basics of trig in the plane. So if you've ever done trig before, you've probably been kind of like stuck with right triangle trig. We're going to move beyond that pretty quickly. But really, trigonometry first comes from studying the measures of the sides and the angles of a triangle. What's interesting is yes, we will deal with that. And actually, you'll see that I think about that all the time, probably because it's the first way that I learned it. We're going to expand this to the study of functions, which are sometimes called circular functions, not triangles. And the domains of those functions are basically the real numbers. So this is a really interesting deviation. So what we got to do to make this happen is we've got to move into the plane. So we're going to get out of our right triangles and we're just going to think about what happens. So like when a door swings, right? A door swings through an angle. Everyone will acknowledge that. Or a skateboarder does like whatever, a 360 or a 720 or a 1080, right? They're just spinning. We're talking about their rotations. That's what you want to start thinking about. You want to think of it as a rotation, like swinging a bat, right? You have an initial position, then you swing it to some sort of terminal position, and then the angle is how much you rotated as you were swinging. So let's see if we can actually draw something. So we're going to think of it as a rotation of a single ray. So the initial position and the terminal position are of the same thing. It's the door, right? It starts out closed, you swing it open, it ends open. It's still just the door. And we're talking about how far did that door rotate. That's our idea. So when we do this, let me just draw like a general thing here. So I'm going to draw a point, and this will be my vertex. And then I need like an initial position. So I'm just going to say that this is my initial position. So initial position. And then let's say that I rotate counterclockwise, right? So counterclockwise, for whatever reason in math, counterclockwise is like the way to go. It's how we have positive angles. When you rotate counterclockwise, you get a positive angle. If you rotate clockwise, you get a negative angle, which I always, when I was first learning it, thought was a little bit weird, but whatever. Let's say we go to here and we do this. This will be our terminal position, right? So you start with the bat facing the initial position, you swing it, it ends at the terminal position, the angle that you went through. So at this point, we don't know, right? Like I'm going to go with the smaller of the angles, but we don't actually know, right? So this could have been our angle, right? So this would be theta, but like there's no way to know. We can't be sure until you draw that, until you draw, the little arc showing which way you went. You don't know that you didn't go this way, right? Now we know because we drew it, but there was no way to know before that. So it's really important in your figures that you actually put that in. Now, what's annoying, what would be annoying, right? If I tell everyone, draw me a 1 radian, right? So if I say draw 1 radian, so 1 radian we know is going to be an angle. Whoop, that didn't work. Hold up. Okay, I'm trying to get a circle here. Okay, 1 radian is going to be, stop, the angle that intersects an arc that is exactly 1 radius of the circle, right? So this would be 1 radian. Now, if I told everyone to draw 1 radian, there's no reason that everyone's radians would be facing the same way, but we want them to be. We want everyone who's just drawing it to end up with the exact same picture so that we can talk about like, well, I put this on the left, I put this on the right, I had it above, I had it below. We need to be able to talk about that. The way we're going to do that is we will standardize the process. And when we standardize the process, we come up with something called standard position. For standard position, there are 2 things that are always true. And those 2 things are the vertex will be at the origin, right? So we're going to literally put it in the XY plane. The vertex is going to be at the origin, and the initial position is going to be on the positive x-axis, always. So if I'm going to draw an angle in standard position, first, I need a coordinate system, set of coordinate axes. And then I'm going to need, my initial position is always on the positive x. So maybe I'll do this in a different color. So usually you don't actually draw the initial position. So this would be initial, And then terminal could go anywhere. It doesn't really matter. I'm going to put terminal, let's say here. Right there. Okay, so that's my terminal. And then the angle, if I'm going to have a positive angle, I will have rotated counterclockwise. So positive angles go counterclockwise. So this, I'll say, is my angle. That's a positive angle. It's positive because I've gone counterclockwise. A negative angle would go clockwise. Hard to get used to. But you can actually see here that there are two ways to get to this terminal position. One of them is faster than the other, right? So let's say somebody else does this and they get this. So I'll say that this is theta. Use a little subscript, sub 2. Use a subscript for the first one. I'll go back and say that's theta sub 1. So one person went counterclockwise. So I'm going to say theta sub 1 is greater than 0. And the second person who went clockwise, so theta sub 2, is a negative angle. So it's a convention. You got to know conventions because there's no way to come up with them on your own. We kind of accept that people before us decided these things. So the terminal position can be anywhere. Initial position has to be on the positive x-axis. The vertex has to be the origin, where the x and y axes come together. So I've already mentioned it several times, but it's worth highlighting that counterclockwise is a positive angle and clockwise is going to be a negative angle. And that's going to come up over and over again. So you got to get used to it. So here we just want to draw some random things. So draw a positive angle in standard position. All right. To do that, I need my x and y axes. I can't believe it made that into a line. I'm actually going to duplicate this while I'm here, just so I can not have to do that again. I'm going to duplicate that and put it over here. Okay, so just so I'm ready to go, all right, so I need a positive angle in standard position. So you don't usually draw the initial position because it's always on the positive x-axis. So I'm just going to draw, what'll I draw? This, and then there, and then there, and I'm going to call this phi, and I will say that phi is greater than 0. I don't have to say that. I'm saying that for you, right? Like in general, when we do this, we know that that is the case. So like you don't need to say this, but because we went counterclockwise, we got a positive value. Let's draw a negative angle. So I don't know, maybe we'll end up here. So that's our terminal position. And then to get a negative angle, we have to go this way. So if you don't put that in, no one can tell, right? Like you have to tell someone which way you rotated. People in general will tend, if they've done a lot of math, they'll assume you went counterclockwise. They'll just assume it. If you haven't done a lot of math, people will generally assume that the angle is the smallest possible angle, which is kind of efficient of people. I'm going to call this alpha. So alpha is a lowercase Greek letter. It's one of the most common ways of denoting an angle, and in this case, alpha is less than 0. It's less than 0 because we went clockwise. So you got to keep track of that. So this is because clockwise, which is often just abbreviated as CW, which is weird. Well, I guess it's not really weird. This is because counterclockwise. This one is one word, which that blows my mind that counterclockwise is one word. The abbreviation for that is CCW usually. I don't really abbreviate them. Actually, I guess I do because I do not like writing the whole thing. All right, how about this? We want to draw an angle that is bigger than 360 degrees, right? So it'll have to be positive, so we have to go counterclockwise. But like, no matter what I draw for my terminal position, it's gonna look like it's less than 360 degrees. I'm gonna put it here. So I'm gonna say that this is my terminal position. Now, how do I show greater than 360 degrees? Well, what I'm gonna do, I'm just gonna loop around, right? So I'm gonna start here. That's 0, that's 180, that's 270, that's 360, and more. So I'm gonna call this alpha, I'll call it beta. So beta is a lowercase Greek letter, but it looks very capital B-ish to me at least. I'm going to say beta is greater than 360 degrees. So why is it greater though? It's greater because we went clockwise and around more than once. So actually, you could draw like any number of degrees. So like you don't want to do it, but like you could have drawn something like, I feel like that is not vertical. Should I do it again? I guess. All right, here we go. Here we go. You know, it's you gotta let it like it like snaps when it gets to vertical. Let's do this. I'm not gonna count it, but I don't know. You just go crazy. You know, draw yourself a little spiral. There you go. That is way more. So maybe I will try to count it. I'm gonna try to count it. No promises here. All right. So this is 360, 720, 1080, 1440. So we're a little above 1440 here. So what should we call this? Let's call this gamma, which I'm not good at drawing. I basically make it look like kind of a diving alpha. I'm going to say gamma is greater than 1440 degrees because we went around once. That was 360. Again is 720. Again is 1080. Again is 1440. And then we stopped in like the first quadrant. So we went less than 90 more than 1440. So we could actually make an inequality. Like gamma is definitely bigger than 1440 and it's definitely less than 1530 because 1530 would be if we got to the y-axis again, which is like 90 degrees. So this is, I mean, there's nothing earth-shattering about this, right? So maybe you didn't know that clockwise was going to be negative, counterclockwise would be positive. It's possible you didn't know that. That's totally fine. That's why we're learning this stuff. The way to draw an angle though it just feels right, right? Put it on the XY plane. Everyone will then get, if I tell everyone in class to draw me a 45-degree angle in standard position, everyone draws the same thing. That's perfect because now all of our pictures are the same and we can just work off of that. So the naming conventions for angles, you just got to be familiar, right? So you'll see alpha, beta, gamma, theta, and phi. Those are like the 5 Greek letters that come up by far the most. Any capital letters will work, typically A, B, C. Doesn't make a difference, could be anything. The easiest thing, depending on how many variables you're going to have, is to just use subscripts. So you can call every angle theta, theta sub 1, theta sub 2, theta sub 3. And also, let me just write that down because one year I had a student who didn't quite know what I was saying. So this is theta sub 1. And then some people just say theta 1, which, you know, is kind of fine, but kind of not right. So it's up to you. You know, if you want to be wrong, be wrong. All right, so there's kind of a lot here. Nothing that's groundbreaking. Standard position is really what you need. Counterclockwise positive, clockwise negative. I'm going to stop this here, come back in the next video, and do some more. Maybe do something with these. Who knows? We'll find out. See you there.